Good morning, good afternoon, good evening, everyone, depending on the day of the time this video is getting played. Myself is Dheeraj, working with NYeC eHealth Collaborative in capacity of Senior Technical Lead Architect. Next 10-15 minutes, we are going to talk about FHIR exploration and implementation done at the NYeC eHealth Collaborative in collaboration with Department of Health, New York State, and other regional health information organization, in short, RHIOs. Since 2015, NYeC eHealth Collaborative have launched Shiny Network, which is statewide health information network for New York State, where we have provided a hub or a central service where all these regional health information organizations can connect and exchange the clinical information. And this implementation is based on the several IHE profiles such as XCA query, XCA retrieve, where we are exchanging the CCD or CCDA document. And each of these regional health entities are independent systems, independent organizations. They have their own infrastructure, they manage their own operations, but they connect with us to exchange the clinical information. So the system have been functioning since 2015 and doing its required functionality, but at the same time, we have been observing certain limitation to it. One of the biggest limitation is the amount of data, the size of the data, which is traveling over the network when it's transferring the data from RHIO A to RHIO B. So because depending on the patient, depending on the amount of data that patient have, sometimes the CCD generation takes a longer time. And by the time the data is generated or the CCD is generated, system might time out or sometimes it crash. So it has to start over again. And even if it finished the generation of the data in time, and when it's transferring the data over the network due to the large size, sometimes we have seen the data is not transferred successfully and there are multiple issues happening. And the another point of failure here we have seen is like even if the data get transferred to the location where it's supposed to, then due to this large size, receiving end sometimes is not able to pass the data, not able to extract the required information out of it for its depending on the size or sometimes the structure of the CCDA. The other issue which we have seen is like some of the use cases are very straightforward where the requester doesn't need the whole CCDA data, the whole complete data. They just are interested in the part of the data. Sometimes the physician just want to see the allergies you have or what is your last lab done. But because the CCDA does not give that option of querying the data discrete way, like a partial data. Now, every time data is needed, whether full data or half data, you have to query the whole CCD and then extract the required data out of it. So since 2015, the system have been functioning, and then we do the weekly validation. There's a rarely we have seen that it's always 100% success. So that is a motivation for us to look for some other things which can transfer the lightweight data over the network, and FHIR specification perfectly fits into that. So we started exploring that in 2019, 2020. We started looking at it. We want to do the FHIR implementation and the Shiny network. Are we ready? So we started doing the readiness study and looking at our all stakeholder and seeing like if they are ready and what it requires for us to get started with the FHIR. After the study in 2020 and 2021, we did a POC implementation. In this POC implementation, we created we called it a FHIR Central Services. It's like a hub built by NYeC eHealth Collaborative to connect different endpoints. And these endpoints are from the RHIOs. And this central services is called as a FHIR Central Service or FCS. And this will have a capability to connect to the different RHIOs. And at the same time, it has a capability to connect to the statewide master patient index, which we will see seeing next. So what we're seeing on the screen is different components or the features of the statewide FHIR Central Services. So the main hub or the engine is called as a centralized service or FHIR centralized service. And this has a capability of connecting to the different RHIOs. So you can onboard any RHIO or offboard any RHIO to exchange the data on the FHIR Central services. FHIR Central services is also integrated with the statewide master patient index, which is the state MPI. And this helps the FCS to discover a patient in case if we want to pull the data from the multiple sources, depending on the request. We will look next. So FCS has a capability to get the data from one single source or from the multiple source. So requester, if they want to get a data from a one single source or one single RHIOs, they can send a request specifying that we just need the data from RHIO X, and FCS will connect to RHIO X and get the data and provide to the requester. But at the same time, it also enables the requester that if they want the data across the SHINee network or across the New York State, they need to send us a request in the form of that they are looking for the data for the SHINee network. In that case, the FCS connects to the statewide master patient index and find out where all other places this patient have been treated and where this patient has the data. Once that is identified, then the FCS connects all those RHIOs and collect the data. And once it gets all other RHIOs responses, it aggregates the response and prepare one single response sending out to the requester. So here we're talking about multiple systems talking with each other over the internet. So security is the main concern or is the main topic to discuss before this communication is established, before the system is implemented. So because here we're talking about very close network, the SHINee network, where we trust each other. So it's basically a trusted network. So here the implementation is done based on the MTLS in place and also the IP whitelisting. So we exchange the certificate with each other and whitelist the IP of the system which are going to talk to each other. And also we have implemented the JWT token, but this JWT token is currently implemented for the audit purpose. So it plays the role of like a SAML, which contains all the required information when one system is sending the request, what is required for other system to identify and audit that particular audit level information for that particular transaction or the request. We also have the future plan of like, if this get to a level where we want to open up to the internet, then the OAuth implementation will come into the picture. So that it can be open as an API. So these are the several components. Let's move on to the actually how the FHIR Central services look like and how it functions. So what you see on the screen is basically a flow diagram for the FHIR Central services. Left-hand side, you're seeing the requester, and right-hand side is the responder, and in between, you're seeing the FHIR Central service model, that is the hub. Built at the NYeC. It has multiple components such as like a service connector and security validation. Then it has a request and response processor and central MPI connector. So any source wants to get a data from the other participating source. They are the requester. They will send a request, and request comes to the service connector. Service connector takes the request and pass it on the validation component, and once the validation is passed, that request is sent to the request processor. Now request processor has the capability to evaluate the request, whether it's a request for a single source or it's a request to get a data across the SHINee. If it is a single source request, the required informations are fed into the request is prepared and sent to the service connector reach out to the single source, get the data, pass on the response to the response processor. Now response processor does the massaging required and pass on the message again back to the service connector, and service connector pass on the response to the requester. So that's a single source. But if it is for the multiple source, then the requester processor connects to the central MPI connector to connect to the statewide master patient index to find out whether this patient exists anywhere else in the community. And if it does, then it gets that data and pass it on the request processor. Now request processor prepares the request for each of these target where the patient exists. and then pass on all the requests to the service connector. Service connector sends the request to the respective target, collects the data, pass on the response to the response processor. Response processor does the massaging and prepares aggregates the response, does all the required logic to create one single response and send it out to the requester. So that's the flow how the FHIR Central services work. And when we were doing the implementation, there were multiple issues we encounter, or I will say the multiple challenges we had. One of the biggest challenges we had is like by policies, we are not supposed to parse the data. We're not supposed to look at the data. So now we are getting, because we were getting the responses from multiple sources, we had to aggregate that response into one single. So we were not sure how we should aggregate the data without actually going through each resources coming in the bundle. So initially we thought that we're going to create a super bundle, and that super bundles, each entry will be a one response from each source, target source. But that is something is not supported by the FHIR specification. That is, the nested bundle is not supported by the FHIR specification, and there is a good reason why it is not supported. So then we took it back and talked with the business and look at the policies, and we decided, okay, we're going to do the in-memory aggregation. So we're going to look at the data in memory and then create a one single bundle, extract all resources coming from the different responses and put it into the one single bundle, and do the full URL resolution and also the pagination. And we are also working on narrative. So all those things worked out in a memory, and then send back the response to the requester. The next challenge which we had is like a multiple FHIR version. Yes, so different RHIOs had a different FHIR version at their side. Some of them were DSTU2, some were STU3, and someone were on the R4. So we worked on some conversion, but now luckily all of them are moving to the R4, so that makes life much easier. So pagination and narrative. So these two are like another burning challenges we had, because each sources respond had their own pagination link into it. Now we had to basically resolve those pagination link in respect to the FHIR Central services. So we had to manage that. So what we did is we created a pagination mapping table where we get each response, each source response, and extract that pagination information and create our FHIR Central services pagination page link and map it to that page link coming from the source. And any requester, when they get the response, if they want to go to the next page, they send the link information which belongs to the FHIR Central services, and then FHIR Central services map back to the response to the pagination link provided by the actual source, and reach out all of them to extract the information. So that is something we have a solution in place. For narrative consolidation, we are still working, because we receive the narrative from each sources. Now, because when we are aggregating this data, we want to make sure that the narrative is still meaningful and it is either rewritten, or there is some other alternative to provide that narrative, and there should be some way to identify and make a meaning out of it. Data quality. Data quality is very common issues even with the current implementation, because it completely depends on the way the data is fed from the source. And if the data is not complete, or data is in a different format, those are bigger challenges. And especially with the FHIR, when you have like a very tightly defined schema, if certain things doesn't fit into the window, it's going to cry. The last one, the changes the FHIR standard level itself. So it's not a big challenge, but current implementation, but it is a challenge, because when by the time we are done with our implementation, if there is a change happening which is going to impact to change the current implementation, depending on if there are some resources which are not normative, So that's another challenge what we're facing. So I will pause here. Thank you very much. Good morning, good afternoon.
Thank you, Dheeraj. I don't see any questions in Whova. Are there any questions from anyone not on Whova? You can unmute yourself.
So, I think if we don't have a question, then I think that will be good. And if there is any additional question, please put it on Goa. I can respond there.
Fantastic. The recording will be available in this space on Whova. And if you would rate the session in Whova as well, that would help us a lot. Thank you, Dheeraj, and thank you everyone for coming.
Thanks, Anna. Thanks, everyone.